We're going to speak today about a new trend that is big data, specifically why big data project fails. The outline for this presentation is three topics basically. What is big data? Why is it so important? And in more details, we're going to speak why big data project fails. There is basic two reasons, which is processes and communication. We'll get to that later. What is big data? Big data is the ability to store, visualize, analyze and find patterns in huge amount of data. Something that could be done in the past basically by the military and some universities. Now every person at home has the ability to connect to those huge clouds and have the ability to design, implement big data projects if they wish to. Why is it so important? Why big data is so important? Because it enables innovation. Many fields benefit from big data. For instance, the health system, the web, finance. Okay, we can give some examples. The IBM Watson technology, for instance, it's able to understand your symptoms, and he gives a recommendation of the best meds and the best treatment for your possible disease. It can support many doctors around the world with very high level of certainty based on a huge amount of data and statistic from all along, So that's one example. A second example is the web. We have Google, we have Amazon. Google is the ability to search billions of websites and pages that are indexed in Google servers, and the ability to return the most probable websites that you are looking for. And in the case of Amazon, is the ability to profile your behavior so they can tell you what is the next product that you may want to buy. Another example is self-driving cars. And people ask, what a self-driving car has anything to do with big data? It truly depends on big data, because you need to take all this data of behavior of other drivers and GIS information, GIS geographic information systems. You have to put all this information together and through some algorithms teach the car how to drive. So even in that example, you see how big data is such a useful thing. Why big data project fails? Basically, as we said before, there is two reasons: processes and communication. As we speak about processes, and we'll dip in now, managers see big data in a somewhat simplistic way. You have a manager on one side that requests a report for his employee. He's not aware of the complexity of making that report. He's not aware of the data integrity that involves making such a report. He's not aware of the skills that the employee needs to build that report, or even if he as a manager have the skills to read and interpret, make an interpretation of the data, take good decisions and actions based on that report. So now we're going to go through a sample process that we're going to build it together. We're going to speak about credit, an example of credit, but you can take this process and take the building blocks that we're going to speak about and implement that on health, on financing, on the web, and with minor changes, I think it can work well. So for those of you that don't feel comfortable with the example of credit is nothing more than, if your company deliver goods or services before it get the last payment, you're actually giving credit to your customer. And the question here is if you can do it better and if you can use and leverage big data to make it better. So a first stage when you start a big data project is regarding acquiring the data. What does it mean, acquire the data? The system is running with users logged on using the operational system of the company. You don't want to disturb them. You want to have a second copy of the data, something that you can play with. And if you make any mistake, nothing happens. You just make another copy of the operational data center. So after you acquire the data, you can move to step 2, which is a stage for clearing the data. What happened is that the data has been input. The input of the data was through some systems and people, and it may have human errors, typos. It may have some really data integrity problems. For instance, if you merge with another company, so you have one data of one type while the other is in another type. For instance, you have an Oracle system and the other company has an SAP. So you have to integrate this data. So you have to clear it, integrate it, you have to unify that so you can really analyze that as you want one chunk of data. The next step is a tricky one. What happened is that most companies don't have data analysis abilities at home, so you have to outsource some abilities. You have to take this data and move to an external company, or even take some professionals from an external company and bring on this project. Your company have a lot of sensitive data, confidential information, and it's most probably that you don't want to have people looking at those confidential sensitive data, right? So what you do is a process called normalization. You're actually coding the data, but keeping the statistical sense of the data, the statistical validity. So, for instance, if you have a client that you have a revenue of a client which is 10 million, you can code that 1. So another client you have 20 million will be coded as 2. It still have the statistic validity. One is 1, the other one is the double. And so it keeps the integrity of the data, but the data analyst that is reading that information, he doesn't see the semantics. He doesn't understand that we are talking about revenue, and he doesn't know if 1 means 1,000, 1 million, or 10 million. When the normalization is over, you get to the phase, of the big phase, the major phase of the big data project, which is the data analysis, made by some statisticians, econometric people, mathematicians that usually analyze the data and try to find patterns and things that we can work with. The next step and the next stage, which is a very important one, is have some kind of economist in the process to, so he can take the output of the data analysis and translate it to something that decision makers can work with. The data analysis stage is so technical, and its outputs is usually in a mathematical language, very difficult to decision makers to really understand what is going. So have an economist to filter that, to translate that to a business language is very useful. And in the next stage, we'll usually go to a credit committee, so they can take the report made by the analysis and translate it by the economist, so they can take really decision based on that. The output of the credit committee will usually be a credit policy. The credit policy will be spread to the company. Usually it will go from some kind of some programmers with very specific skills, usually within the company, that will build the rules, the operational rules that the company will work with. And then we go to a very natural process of monitor, control, improve. And that's our process, 11 stages, very simple. But you see the real difference between what is a simplistic view of a manager with give me that report and not understanding actually what is happening behind the scenes, and really taking responsibility over the process with all its stages. So in summary, if you want your big data project to success, first of all, you want to build a process, design, plan it in such a way that you will find all the possible errors and mistakes in those phases, and not when the manager is actually taking a decision on wrong data or wrong knowledge or bad data integrity and so on. If you want to have a big data project to be a success, you have to take care of another thing, which is communication. Here we have two subtopics. One is multidisciplinarity, and the second one is context. Multidisciplinarity, what I mean by that? If you listen, if you just look at what we just said about process, how many stages there is in such a very simplistic credit process. You see, there is every phase there is a different professional with different skill levels required to do the job. So the truth is that Big Data project is a multidisciplinary project. Each person comes from a different profession, like the person can be a statistician, a mathematician, you have an economist, you have decision makers, you have policy makers, you have programmers. Each of those people have their own professional language. They speak a different language. So let's take, for example, some wording that a data analysis professional will use. So suppose that you are a decision maker and I'm now in the technical role going to speak with you. Don't get offended with any of the words I'm gonna say, but he's gonna speak to you about support vector machine, KNN, regularization, convex optimization, and neural networks. That's the kind of wording he's gonna speak with you while trying to specify or explain how he's doing his magic, his data analysis. Yet, the business guy, the decision maker, he speaks in a total different level. He uses business terminology. He will understand clearly what is cash flow, what is financing, what is return on investment. So how do we expect those two people to communicate? So a very important stage in the communication issue is that each person in each stage has to be able to understand what the previous stage is speaking, and he does his processing, and he has to know how to communicate those findings to the next stage. So in that way, you make sure that everybody speaks the same language in understanding each other. But it's not over there. It's not enough to understand the previous and communicate to the next one. You need another level. We have to speak about something which is the context. A good example is that you may go public and say that 100% of the people which drink water dies. So you are in a bad context. You can speak about the number of death in car accidents in Brazil. It would be something around 60,000. But what does it mean? Is it a lot? Brazil have 200 million people, so is it 60,000 people a lot? So you can go to a per capita rate, and you'll find out that actually Brazil has the worst per capita rate of car accidents in the world. It gives a context. Understand exactly what is your situation compared to any other country in the world. You understand that the situation is very bad, that the actions has to be done. When the data is alone by itself with no context, it's very difficult to understand. It's very difficult to decision makers to understand. So the finding by itself has to put some context with it. So now let's go to another and last example. The case of American Senator Elizabeth Warren. She was a professor at Harvard Law School. She made a study of the mid-class of the United States, and she wanted to understand why she feels that mid-class families today suffer more than in the past. It can be just a thought, but it can be true. So she went out to search for that kind of information. It was a huge and long study that she made. And she found out actually that, yes, mid-class families today struggle more than in the 70s or the 80s, even the 90s, basically because of three reasons. The health, housing, and education are much more expensive to the mid-class today relative to what it was in the past. She made a contextualization. She compared 2 points of times and make it very clear to understand that we have a problem now. She got to some important findings about the resilience of the family today. In the past, just the man work, and if something happened to the man, the women could go to work and keep the family safe with some income. Today, if something happened to the man, the wife could go to work and bring home some income. So the family as a whole was safe. What happened today that if something happened to the man or the wife, the whole housing, health, and education is compromised. The family will go bankrupt. The point here is showing the example of Elizabeth Warren, and that she created a context that is so clear that it's very easy to know what to do next, or to think about solutions as you know that the problem really exists, and how it is built, and how it is compared to something from the past, compared with the past. So summarizing this whole presentation, okay, your big data is gonna fail unless you pay attention to the process, to designing, planning, and building it properly, and if you put all the efforts to understand how the communication works in both levels. One is the multidisciplinarity. You're talking with people with different professional languages. They need to understand each other, and you're responsible for that. And the second one is the contextualization. Otherwise, the data itself is meaningless. You don't put any context to that. If you do those two things with process and communication, your big data project will be a big success.